Welcome to Channel 137, where we don't just explore the mysteries of the universe, we challenge the boundaries of what we think is possible. Today, we're diving into one of the most mind-boggling concepts in physics, the speed of light. Could breaking this ultimate barrier unlock access to other dimensions? Could it even be the key to time travel or something we've yet to understand? The speed of light, at nearly 300,000 kilometers per second, is often thought of as the universe's ultimate speed limit. Nothing with mass, according to Einstein's theory of relativity, can reach or exceed this speed. But what if there's more to this limit than we realize? What if we've misunderstood what happens when we approach it? Could we tap into forces that allow us to bend the very fabric of reality? It may sound impossible now, but breaking the sound barrier once seemed just as unattainable. Let's start with the sound barrier, a much slower limit we conquered in 1947. When Chuck Yeager flew faster than sound, people didn't know exactly what would happen. They thought the aircraft might be torn apart, but what followed was a sonic boom, a loud explosion as the air compressed and the plane broke through the barrier. Now think about this. The speed of light is nearly 900,000 times faster than the speed of sound. So what happens when we break that barrier? Could there be a light speed boom? Maybe not an audible sound, but an explosive release of energy so immense it could ripple through the fabric of space-time itself. If breaking the sound barrier revolutionized aviation and space travel, breaking the speed of light could revolutionize reality itself. But what would that even look like? Would we see shockwaves of light and particles stretching across the universe? Could we unlock new kinds of energy or access realms of existence we've only speculated about? To understand what might happen, we need to look at the relationship between speed, light, and time. As Einstein showed, the faster you move, the slower time passes for you relative to someone who's stationary. If you were to travel at near light speed, time would slow down dramatically for you while years could pass for those left behind. This is called time dilation, and it's been proven in experiments with atomic clocks on high-speed planes. So, what happens if we go beyond light speed? Could time behave even more strangely? Could time reverse? Could we travel backward, not just forward in time? And here's something even more fascinating. Every time we look up at the night sky, we're seeing the past. The stars and galaxies we see are so far away that the light we're looking at left them millions, sometimes billions of years ago. So when you gaze at a distant galaxy, you're essentially seeing it as it was millions of years ago. We're time travelers, in a sense, witnessing ancient history with our own eyes. But what about the other side of that equation? For those distant galaxies, we're the past. If some advanced civilization in a far-off galaxy could see us, they'd be looking at Earth as it was millions of years ago, before humans even existed. So, in a way, we are all locked into a form of time travel, just by observing the universe. But what if we could actually move at the speed of light or beyond? Could we leap forward in time, bypassing the slow passage of time altogether? Now let's take it a step further. What if breaking the speed of light doesn't just allow us to travel through time, but also through space in ways we can't yet comprehend? Some scientists speculate that at light speed or beyond, it's possible we could warp space-time itself. Imagine this. Instead of traveling through space in a straight line, we could fold space, creating shortcuts, wormholes, that connect distant points in the universe. This would mean traveling to far-off galaxies in an instant, bypassing the immense distances between stars. Instead of light years, we could be looking at travel times of mere moments. Could breaking the light barrier open up such possibilities? Could we find shortcuts through the universe and maybe even through different dimensions or timelines? The implications are staggering. One of the biggest challenges, of course, is the energy required. To even get close to the speed of light, we would need a massive amount of energy, far beyond what we can currently produce. But what if we could tap into natural forces that already contain vast amounts of energy? Consider lightning. A single bolt of lightning contains up to 1 billion volts of electricity released in less than a second. That's more energy than we use to power entire cities for brief moments. What if we could harness that power? Not just for electricity, but to push spacecraft or other objects toward the speed of light. Could nature itself provide the energy we need to break this cosmic barrier? And what about ancient knowledge? There's speculation that ancient civilizations, like the builders of the pyramids, might have had a deeper understanding of energy than we realize. The pyramids, in particular, have fascinated researchers because of their unique electromagnetic properties. Some believe they might have been designed to harness natural energy from the earth and the sky. Could these ancient structures have been tapping into forces we've forgotten? Could they hold clues to unlocking the immense power needed for light-speed travel? Of course, this is speculation, but history has shown us that forgotten knowledge can often lead to breakthroughs we never expected. What if the key to light-speed travel is hidden in the past? Now, let's shift focus to something happening right now. In particle accelerators like the Large Hadron Collider, scientists are already moving particles at nearly the speed of light. These particles are traveling at 99.999% of light speed, so fast that time nearly stands still for them. The distances they travel contract, and their experience of time is completely different from ours. If we could replicate this on a larger scale, sending spacecraft or even humans to those speeds, what would happen? Could we send people to the future, or even to distant stars, in a fraction of the time? Could this be the first step toward practical time travel or interstellar exploration? And here's another thought. If particles can move at nearly the speed of light, are we already seeing hints of faster-than-light phenomena? What if the speed of light isn't the ultimate limit after all? The WOW signal detected in 1977 remains one of the biggest mysteries in the search for extraterrestrial life. Some speculate that it could be a signal from a civilization that has already figured out how to travel faster than light. If so, they might be trying to communicate with us across vast distances using methods we haven't yet discovered. Or even more intriguingly, what if the signal came from the future? What if it's us, sending messages back through time to unlock the secrets of light-speed travel? Could breaking the speed of light allow us to not just move faster, but also communicate across time and space? The answers could already be out there, waiting for us to discover them. As we explore the possibilities of light-speed travel, we're not just looking for ways to go faster, we're searching for ways to transcend our current understanding of the universe. So, what do you think? Could breaking the speed of light unlock new dimensions, bend space-time, or even allow us to travel through time itself? The mysteries of the speed of light may hold the key to understanding the universe in ways we've barely begun to imagine. Thanks for joining us. Until next time, keep wondering. And if you enjoyed this journey, please subscribe, and stay with us as we continue exploring the unknown together.